Alright, 2.5 more graphing systems of equations. So in this module, we're just going over the ways we graph and then just talking about graphing systems and just showing a lot of problems, get that practice. So one way we can graph is when we're given the x and the y-intercept. Now the intercepts are where the line crosses the x-axis and the y-axis. And plural form of axis is axes. Okay, so the x-intercept is always going to be a point with an x value and the y value of 0, because the y value of 0 on that x-axis is the way it is. So for the y-intercept, its point is always 0 and then the y value. So y-intercept of -3 is 0, -3. X-intercept is 3, 0. So if I graph those 0, -3 and 3, 0, I have 2 points on the x and the y-axis together. Then could I, find the slope? Yeah, 1, 2, 3, 1, 2, 3. So up 1, 2, 3, over 1, 2, 3. Or down 3 to the left 3. I could do that, or I could just use the 2 points I have to draw my line. So if I know my x and my y-intercept, it makes it very easy. Okay, now, if we're talking about the standard form of an equation here, I can actually use the concept of the x-intercept and the y-intercept, okay, to help me. That's one way we can graph when you have the x and the y on the same sides. That's an easy way, because x-intercept and y-intercept always have zeros in them. In the equation, I simply mimic that, okay, because I know that for the y-intercept, the x is going to be 0, and then all I have to do is solve for y to find out what the y value is. And it works every time when you're looking for the y-intercept. Just make that x 0 and solve for y. That gives me my y-intercept 0, -5. Okay, for the x-intercept, same idea. Make the y 0. And then you solve for x. Sometimes they don't look as nice, but you still come up with that answer. So 5 divided by 6 would give us 0.8333 repeated. So about 0.8, so almost at 1. So it would be 5/6, 0, or 0.80. Okay, so it would be almost to 1, right about there. From that, I can draw my graph. Okay, that's one way we can do it with standard form. But it seems like a lot of people don't like doing it that way. So there is another way we can do it. And this one involves using the slope-intercept form, which most of us are a little bit better at graphing. So we just turn this into slope-intercept form by getting it to be y equals something x plus something. To do that, first I'd subtract the 6x. So I get -y equals, clear some space here. Now, remember that -6x is like 6 x's being minused. Okay, it is not a number 6. 6 stands for how many x's there are. So 6x and 5 cannot be combined, so you have to separate them like that. Then to get y, that negative away from the y, we divide everything by -1. So we're left with y equals positive 6x minus 5. Okay, the slope, 6 over 1x, y-intercept, -5, which we already knew the y-intercept, right? So we go right there, then up 6, and over 1. Okay, and notice that we did a pretty good job of placing our x-intercept as well. So a lot of you prefer this way, and if you understand how to do that, that's great. Do it. It works. But there's also that x-intercept and y-intercept method that you can use. Now, standard form has the x and the y on the same side equal to a number. That's the format. What standard form is great at doing is helping us with story problems. A lot of times we can look at a story problem and create a standard form equation very easily based off the information. So great for that. Great for finding x and y intercepts, not so great for graphing often. It's a lot more difficult to do most of the time. Alright, so slope-intercept form, that one should be the one we're most familiar with. Okay, y equals mx plus b. M is our slope. We keep it as a fraction with the top number telling us if we go up or down, the rise, the bottom number to the right or left. And when we're dealing with our slopes, you have positive slopes and you have negative slopes. Those positive slopes are always going in this direction. Okay, if I have a graph. From left to right, they're always going up. Could be barely going up, but they're always going up. So the way we think about a positive slope, if I've got two positive numbers like 5 over 6, okay, I can go up and to the right from the y-intercept. Or if I run out of space, I do the exact opposite, down and to the left. Okay? And that's what we do with a positive slope. Now with a negative slope, like ours, negative 5 over 2, you can think of it kind of the opposite way. We're going down this time. So to get that shape of going down, we're going down and to the right, or we can do the exact opposite, up and to the left. Will get us that same result. So that's our slope. So on ours we'll go down 5 and to the right 2, or up 5 and to the left 2. Now the b is our y-intercept, which we already know is going to be 0 and then some number, and that number is whatever b is, positive or negative. Here's a minus 5, so our y-intercept is 0, negative 5. So we plot that point on our y-axis. Then we look at our slope. Down 5 to the right 2, well, we're running out of room, right? So we want to go up 5 to the left 2. We can go up 5 to the left 2 again. And there's our line. And there's slope-intercept form. The best thing about slope-intercept form, it's easy to graph. It tells us where to start, tells us how it's growing. It's great to use with tables. If you're given a table, you can usually find the slope-intercept form very easily. And great for that visual of graphing, that easy way to graph. Okay, now, if we're just given a random equation, something like this, okay, there's a lot of things we can do. We can always make a table, right? X and Y, pick some X values, find the Y values, and plot them. That's always a great thing to use, but it's slow. Okay, we can also use the X and Y intercept, which is essentially like making a small table and having the X equals 0 and the Y equals 0, then figuring out the Y-intercept, where that belongs, whatever number that is there, and what the X-intercept is, whatever number that is there. Okay? Or you can also just turn it into slope-intercept form again. Okay, on this one, I'm just trying to get the Y by itself. So I could add 25 to both sides, giving me 5y plus 9x equals 25. There's standard form. Then subtract 9x. 5y equals negative 9x plus 25. Divide everything by 5. And I get y equals negative 9/5 x plus 5. That's honestly the easiest way to do it, because you only do the problem out once. Here, you're going to do the problem out 3 times. Here, you're going to have to solve it out twice. Slope-intercept, you do it once. So then I'd go up to 5, down 9, over 5 to the right, because it's a negative slope, so I know it's got to go down. Okay, and there's the ways that we can graph. So, when we're given a system of equations, we simply graph both of them and look for where they intersect. There's a lot of these problems. So, slope-intercept for this page, so positive 3. Slope of negative 4 over 3, so down 4. To the right 3. There's my first graph. Second one, x minus 4, start at negative 4. Slope of x, which a slope of x would be 1 over 1. So up 1 to the right one, up 1 to the right one, like that. Where do they intersect? Right there, at 3, negative 1. That's our answer. So, let's look at this again. Now notice something right off the bat with number 2. These have the same exact slope, right? But different y-intercepts. So there's something that's going to happen. So let's see. So negative 3, then our slope is down 3 to the right 1, or up 3 to the left 1. Our second one, y-intercept of 4, same slope though, so down 3 to the right 1. Okay, now notice, different y-intercepts mean they start at different places. Same slope means they're going to travel at the same, so they're actually going to be parallel lines, which will never intersect. So this is one of the times when you would have no solution, because they don't intersect. We can have one solution like this when it's a point, which is often the case, but sometimes we get parallel lines that have no solution. So that's all you write there. And that's when they have the same slope, different y-intercepts. Let's take a look at 3. Okay, so let's just start graphing them. Notice we don't have the same slope, so most likely they're going to be intersecting somehow. So positive, so up and to the right. So up, can't draw an arrow apparently, there. Up 1 to the right 2, or to maintain that same direction, down 1 to the left 2. There's our first line. Second one, negative 3, and then negative 3 over 1, make it a fraction, down 3 to the right 1, or up 3 to the left 1. Oops. Oh man, I'm having troubles here, aren't I? Up 3 to the left 1. And it's a good idea to draw every single point that you can, because then it makes it clear where they intersect, because sometimes we don't draw the straightest lines. So one answer at negative 2, 3. Okay, positive 3 for our y-intercept, 6 over 1, so down 6, 1, 2, 3, 4, 5, 6 to the left 1, because we couldn't go up. There's our first graph. Second one, start at negative 4, negative x, so that's like negative 1 over 1, down 1 to the right 1, or up 1 to the left. We can see where they intersect at one answer at negative 1, negative 3. As soon as you know where they intersect, draw your line. You don't need to waste time there. Okay, now we've got some standard form equations, so we got to do some extra work. Alright, so there's all those different methods we can, but since most of you usually put it in slope-intercept form, that's what I'm going to do. So our first equation, negative y equals negative 2x plus 1, divided by negative 1. And we get y equals positive 2x minus 1. Do the same thing to the second one, subtract 2x from both sides. Get negative y equals negative 2x minus 2. Divide everything by negative 1. Y equals positive 2x plus 2. So then we graph them. So negative 1, so we go up 2 to the right 1. And you should notice here pretty easily, same slopes again, different y-intercepts. So it's actually going to end up being parallel. So the answer is no solution. Alright, let's take a look at number 8 now. So in this one, subtract x from both sides, we get negative 3y equals negative x minus 9 divided by negative 3. And we can think of that as 1. So it would be y equals positive 1/3 x plus 3. Then number 8, you'd subtract 7x from both sides to get negative 3y equals negative 7x plus 9. Divide by negative 3. You get y equals positive 7/3 x minus 3. So we know we can graph them both. Negative 3, and we'd go up 7, 1, 2, 3, 4, 5, 6, 7, to the right 1, 2, 3. Draw your graph. Go with the other one, positive 3, then up 1 to the right 3. And we can see exactly where they intersect. So there's our answer, 3, 4. So, same thing again. Subtract x from both sides. We get 4y equals negative x plus 8. Divide by 4. We get y equals negative 1/4 x plus 2. So we graph that up to 2, down 1 to the right 4, or up 1 to the left 4. So there's our first one. For our second one, we would subtract 3x from both sides, giving us negative 4y equals negative 3x plus 8. Divide by negative 4. We get y equals positive 3/4 x minus 2. So go down to negative 2, then up 1, 2, 3 to the right 4. I can see exactly where they're going to intersect at 4, 1. There's our answer. Okay, now number 10 is all crazy. So I would start off by subtracting 4y from both sides to get negative 4y equals x plus 8. Then divide by negative 4. We get y equals negative 1/4 x minus 2. So down to 2, down 1 to the right 4, or up 1 into the left 4. Draw your line. Then we do this next one, so I could add a 4y this time to both sides, giving us 4y equals negative x minus 8. Divide by 4. We get y equals negative 1/4 x minus 2. Now notice, we've got the same exact line. So if I graph it, same exact place, so they're overlapping. This is our third type of answer. When they're the same line, so they overlap, so they're always intersecting, so we say it has infinite or many solutions. So we've got one, infinite or many, and none. Those are our different types of solutions. We've got 3 different types. Okay? Now if we look at 11, that one's pretty crazy. So let's do 12 first. Okay? So this one, I could add 2x, right, to get the y by itself. So we'd end up with negative 3y equals 2x minus 3. Divide everything by negative 3. We end up with y equals negative 2/3 x plus 1, because 3 over 3 is 1. So we can easily graph that down 2 to the right 3, to the right 3, or up 2 to the left 3. There's that one. And our second one, we could add 3x to both sides, getting us 9y equals 3x minus 18. Divide by 9. You get y equals 3 over 9 is 1/3 x minus 2. Down to negative 2, up 1 to the right 3. See exactly where they intersect at 3, negative 1. There's our answer. Okay, now let's clear some space for this number 11, this crazy looking one. Okay, so if we look at this, if I add y to both sides, we'd be left with negative 4 minus 7/2 x equals y, which I could rearrange to y equals negative 7/2 x minus 4. Then it doesn't look too bad, right? Start at negative 4. We'd go down 7 to the right 2, so we could also go up 7 to the left 2 to do that one. So not so bad. Now on this one, we have negative 24 over 7 equals negative 3x minus 6 over 7. Why? First thing I would do is, noticing these 7s, I would times everything by 7. Because those 7s would cancel out, we'd be left with negative 24 equals 7 times negative 3 is negative 21x. And those 7s would cancel, so we'd have minus 6y. Then I could add 21x to both sides. So we get 21x minus 24 equals negative 6y. Divide everything by negative 6. We'd end up with that would become y equals, or we could honestly just switch it out onto the left side and go y equals. This right here, we could divide them both by 3, and that would be 7 over 2x to the negative. Negative 24 divided by negative 6 would be a positive 4. So we've got the same slope, different y-intercepts, so these are going to be parallel, aren't they? Yep. So this is a no solution right here. Alright, so not too bad in the end. Alright, 2 more. The last 2. A lot of examples here, right? A lot of examples. So, first one, add 8 to both sides. We get 4y equals 6x plus 8. Divide by 4. We get y equals 3/2 x when we reduce, plus 2. So up to positive 2, up 3, to the right 2, or down to the left 2, down 3 to the left 2. There's my first one. Second one, we could subtract 8. We get 2y equals negative 3x minus 8. Divide everything by 2. We get y equals negative 3/2 x minus 4. So down to negative 4, up 3, to the left 2 because it's negative, and we see where it intersects, and that was a horrible line, but I know it intersects right there, so negative 2, negative 1. And our last one, add 2x to both sides. Wait, no we don't, because the y is already by itself, right? So we just want to divide everything by negative 8. So negative 2 divided by negative 8 would be positive 1/4 x. 16 divided by negative 8 would be negative 2 equals y. So down to negative 2, up 1 to the right 4, or down 1 to the left 4. And this last one, we would want to subtract 12. So we get negative 4y equals negative 6x minus 12. Divide everything by negative 4. We get y equals 3/2 x plus 3. So up to 3, up 3 to the right 2, or down to the left 2. And we see where they intersect right there at negative 4, negative 3. And there we go. There's a bunch of examples of how we graph these systems.